Yes, that's an honor of life.
So this is the POC.
This is Blake. This is what he looks like when he was younger. All right. Here we go. So I'm going to talk about partial object caching, which is the never-ending project that I should have finished 2 years ago, and I want to really deeply apologize for not getting this done sooner. It's still not done. I am working on it, and we're going to give a little quick update on where we are on this. This is a fairly major feature with lots of implications. I'm going to do a little recap from last time for people who weren't here, what we're actually doing here. The basic thing, you want to be able to handle range operations for HTTP. And this means fully handle. Right now what happens is if you can serve ranges if you've already preloaded the entire object. What I want to do is to say, if you just request ranges, we can handle that. This involves major changes to the cache implementation, but we're still going to be backwards compatible. Be very careful about that. You can be able to load this and keep running on your old cache. You won't be able to go back, though. Once this starts writing stuff to cache, it's going to be a format that the current stuff won't be able to understand. This also doesn't involve a lot of other projects because it involves messing around with the same bits of code, which are all complex. So I wanted to try to do these all at once. Probably a mistake, but that's how we roll. So we want to improve read while write. We want to put the origin connection collapsing in the core. There's plugins that do this, but they're kind of flaky because a plugin simply can't get at the right stuff to do it well. It's not possible. We want to move the stale or revalidate support back into the core. Again, it's the same problem. The plugins simply can't be made to work particularly reliably because they don't have access to the right data. They have to play funny games with the URLs and the requests and the hooks, and it's baroque and therefore does not work well. It just has to get the core to work well. I'm also looking at some better locking and polling. There's been issues with the cache in terms of the locks being held too long and being a little too broad. I'm trying to make them finer grained so we have less lock interference. I know that, for instance, Yahoo has to split its caches to multiple volumes simply to get less volume to get the performance. So this is an issue I'd like to do better on. We actually looked once upon a time at doing a major update to the locks for all of traffic server. Say, well, let's have more condition type variables where rather than doing polling, you can wait on the lock and get woken up. But we did the performance measures. As far as we could tell, the cache locks were the only ones that really had a problem. So it didn't look worthwhile to do this as a more global, so one of the effects, this is still recap here that I want to talk about for to be clear on is request quantization. So if we get a range request in here to traffic server, when we request out to the origin, we're going to quantize that request. Because it turns out in traffic server, for reasons we really don't want me to go into, we have to store the content out on the disk in fixed size fragments, and those fragments have to be there or not be there. Keeping track of variable sized fragments, we looked at that, it's simply too complex and it's not. It's really, really ugly. So in this case, what we say is either if we see these fragments, it's either there or it's not. And we pick an appropriate fragment size, which is currently about 1 megabyte. That's tunable actually, up to about 16 megabytes, I think. So when we actually send the request out, we're going to expand it out to these boundaries. We're going to pick the set of fragments, the smallest number that covers the initial incoming request. So that's what actually would go out to the origin server. There's a couple other features that we need for performance reasons that are desired. One is the initial quantization to say, it creates a little bit of an inefficiency if this first fragment isn't there initially, because the way ATS stores its cache. And also the first stuff is most frequently. So one thing that we'd like to do is people say, well, if this gap isn't too big, go ahead and request it anyway. Right? So we want to make that a tunable parameter to say, yeah, this much, I'll prefix this much from the beginning if it's close enough. We also want to have an interstitial quantization. I just did that because it's a fun thing to say. What this is to say, well, we have gaps in here. If we have a multi-range request that comes in, we have these little gaps, we should fill them in if they're not too big again. We'd like to make it a configuration parameter to say how too big it is. Right? You don't want to be pushing this stuff up. Actually, no, that's not true. Let me rephrase that. We can't depend, according to HTTP spec, any origin has to be able to serve single range requests. right? It doesn't actually have to send a 206 back, but it has to be able to understand and parse that, and at worst hands you back the entire object. Origin servers are not required to understand multi-range requests. They can simply fail on that. They can give you a 400. It is not required, and you cannot assume that at all. So we actually, coming back to that, we have to do this interstitial filling so that we don't send multi-range requests out. And there's another.
So you, in this implementation, you never send a multi-range upstream?
Correct. Because we simply can't depend on it. It's not reliable. It could easily break, and there's nothing we can do about it.
Do you see multi-range requests in the wild?
Yes, but they're extremely rare.
Do we not just want to send multiple range requests?
That's pretty hard too. That was discussed, and I think it's not worth the implementation.
So, what's the trigger to fill these gaps? After you first get the first response, first single byte response, or you do it in parallel?
Well, no, we're going to change the actual request you send up so the request doesn't have a gap.
Okay, so you widen it. Okay.
Yeah, we'll say we're going to request this whole chunk here.
The gap is small enough?
Well, actually, that's a good question.
I'm not clear to understand.
Yeah, you're right. Sorry, it's been too long. We're directly on the code. Yeah, that's right. So we always just fill in the gaps. And send that off. So if someone requests a piece here and here, then we're going to end up requesting the whole object. But that's not really a problem because they could have just as easily requested the whole object in the first place.
I'm wondering if this is kind of open to DDoS. Somebody can keep sending distinct ranges and you keep trying to fetch additional
Well, not really,
objects.
because they wouldn't do that. Why not request the whole object? Why go to the complexity of putting range requests in as opposed to just saying get?
No, but for them it's less bandwidth to request single range, but for you, you're trying to fill the cache with all these gaps and you'll eventually run out of cache space.
Because I can ask for the first 20 bytes and you'll get first 20 bytes, the last 20 bytes, and you'll load it.
Yeah.
But if you get, just call it get and import, right?
Yeah.
During patch.
But that's no worse than
Depending
today,
on how
because
many
if you're
bytes.
scanning through the object, you'll end up getting the whole thing.
Yeah.
Today, if you're scanning through by
In
objects, you
fact,
get the whole thing, and this would end up eventually just doing the whole thing.
Yeah. Yeah. So, I mean, in fact, the request I actually get on this is to say, if they send that small request, I want to actively fetch the whole thing. Right? This is what background fetch does. So, I don't see that as a real concern. Another thing, so thinking these as two separate requests, another fun thing is we can get suffix requests, and we want to pad those out this way, so we try to get a full fragment here, right? We can store a partial fragment as the very last one, but we'd like to push this back, because if we don't get at least cover this partial one here or up to here, then we may not be able to capture it all, and we'll just keep making requests and keep hitting the origin. We'd like to fill out enough, and we'll cache some of it. Right? So if we move this out to be a full fragment width, worst case is we can cache that. So that's one of the things we have that I'm working on. Let's see. And final, one last recap here. This is a big issue for a lot of people, is that we have an initial request, a reasonable request that says, I just want to get this object, and it's a large object, a couple hundred meg or a gigabyte or something. And we start fetching it and filling it out and sending it out to the user agent. And then the second request comes and says, I want this piece over here. Right. One of the things we're doing to minimize load and origins, we'll say, oh gosh, we already requested that fragment, so we'll just wait for it to show up. Right? But if this is a gigabyte object, that could be minutes away. So we have to have a parameter that says if it's more than so many bytes downstream from where we're actually fetching now, go ahead and initiate another request. Because you don't want, because this guy's going to see this really mysterious, tens of seconds delay for no reason whatsoever, because this guy can't get in first.
That's not right for the cache too, the second request?
Yes, what will happen is, logic's in there to deal with that. We'll check when one of these fragments arrives, it looks to see if it's already in cache, and the hash just throws it away. So it's tracking all of that, and whichever one shows up first, it brings.
And then if a third request comes in asking for the same laid block, that will sort of attach to them.
Yeah, so in that case, what will happen is they'll come in and say, we have a request that's actively fetching that. It's not too far away, so I'll wait for it. right? So if your distance is far, it makes it harder to stack up a bunch of requests that are all trying to go to the origin, because each time you do this, you say any request in this chunk here is going to wait, right? Here, here, and so it fills up fairly quickly, depending on your tuning parameters. But this is very important for video, right? Because people do this a lot. You don't want to get that waiting. So what's the current status? I'm currently testing production. That's not going particularly well, but it is a step forward there. It's currently written on a 6.2 base, so I thought I'd get out for 6.2. I'm going to be forward porting it to 7.1. This will be the 4th time I've ported the version, which is entirely my fault. So I'm still working on some of the still revalidate issues. I have some backwards compatibility in, but it's not quite finished yet, so I need to do better on that. Else.
So Alan, on the point of backwards compatibility, so is this feature optional? Is it toggleable?
No, unfortunately, it's not going to be optional. It's just too complex to do that. It's going to just change the way the cache works.
So once you turn it on, there's no going back.
That's correct.
You have to dump the whole cache.
Yes. But we have that problem now anyway. Even if we change the WKS strings, once you go forward and you try to go back, it breaks. Now, one thing we did do in the 6.0, was that for 6.0? The cache objects are now per object version. So we can actually look at the version object for each, the version of the cache for each object we stored, so we can figure out how to decode that particular object, which makes forward upgrades a lot, makes backwards compatibility much simpler. So this would mean we'll be able to read caches all the way back to 3.2. At some point, we're going to have to rip out that old stuff.
So can you also explain how it works? Probably you already did, I missed it. How it works when you have a bunch of small fragments filled up, and then there is a parallel full object request. You download that. What happens? How do you?
Okay, so what happens in that case is it will unfortunately have to refetch some of the stuff that's already cached. You'll have to fill in the interstitches and fetch it out. It will pick the single range request, the smallest possible one that gets all of the content that isn't cached.
So every time there's a request, you will see if there's some parts of it that's in the cache and only fetch the gaps.
No, we'll pick the smallest single range that covers the gaps that aren't already cached.
Okay.
So if you do have a lot of gaps that are spread out and you do a big request, you pick a couple of pieces that are widely separated, then yes, we'll probably tend to switch to get the convex hull of that. And I don't think it's worth it to try and avoid that, because again, you can always just fetch the whole object anyway.
Right. So that while you're basically processing a request, you are determining all these gaps and finding out the ranges that you need to fetch. That's one thing. The other thing I was wondering about is, even though you requested a single range, the origin will still give you a full object. In this case, let's say you determined that you had to fetch a couple of ranges.
Yes.
But the origin returned you full object. How are you going to store that in these gaps? Are you going to break the object into pieces?
Yeah, well, it ends up actually being the same case as this, right? It's just the flip of this. So let's say the original request comes in, this is the initial one, and we say this, and the origin actually returns as this. So we just handle that. We can see when the data comes back, the origin has to tell us where this is in the location in the object. So we just start writing it out. And so it's all very fragment oriented. So we receive data, and we fill the fragment that's cacheable. We say, is that already there? Yes. Then we drop it. If it isn't there, then we write it. And we just do that every time. So it ends up being the same. This is one of the reasons it's a bigger project. Is these problems are just flips of each other. And the technology that fixes one handles the same thing. It's just like the fact that we have to have multiple writers in this case makes the connection collapsing easy. Because once you solve the multi-writer problem, then, well, it's easy then, right? Done the hard part. Let's see.
So once you get this out, connection collapsing and still while validate will be optional that you can turn on and off, or?
Well, the connection collapsing, I'm going to actually talk about that in a little more detail in a bit. The connection collapsing will not be optional. That'll just happen because they're really not worth making it not happen. The stellar revalidate, of course, these will be tunable, right? You'll be able to say, do I want to stellar revalidate? What things do I want to do? How stale am I willing to serve? So in some sense, it won't be optional, but you'll be able to tune it, say, and effectively turn it off by saying, zero length stale is what I'm willing to serve, right? We'll say, oh, well, no, you can't do that. So yeah, trying to find the work. I'm still finding out things about how the cache works. That's really been fun. This stuff is really, it's been lost technology, and edge cases are just killer. Let's see. So, this is our data structure recap.
We all remember this from last time, right?
Yes.
Yeah.
This should be familiar to you all. This is some of the stuff that's going on inside the cache when we're storing stuff. Yeah, I had some problems with this recently. This is where we store, well, anyway, you don't honestly care. I just like looking at my diagram. Yeah, so this is the kind of structure we have going on. And we have cache received waiting on the open directory, which tracks an elephant object in it, and the alternate vector, and tracking all of that. So each alternate that we're actually writing has a list of writers and readers. And one of the things we're doing for locking is right now, if you have a read while write, the readers will see if the thing is in cache. If not, we'll put in a 10 millisecond delay to get an event in 10 milliseconds. And just do this polling. So if you have a lot of readers on a writer, you can really get hard. So one of the things we try to do is here, because we track the readers on the thing, when the writer writes something to cache and it's been written, it can go and it can tell the readers, hey, wake up now. So the readers don't poll. They just go to sleep until someone writes a cache fragment out. You can actually look and see which cache fragment the reader is waiting for and wake up the ones that would be of interest. We actually try to pass it along through this side content buffer here, so it doesn't actually have to go to disk. We can stuff it in the side buffer here and directly take out of there to memory. In fact, it's a little mini RAM cache just for this particular alternate. I have to be careful with that. I'm a little concerned that you can have a fill problem here where you can end up consuming a lot of memory here for large objects for stuff that's not actually being used now. So I'm still looking at that.
Functionally, you could get rid of that as just an optimization, right?
No, it turns out it's not.
Not enough.
What happens is what you really need this for is pieces of data that the ordinance sends back that don't fit in a fragment and can't be cached. Because I can't control that. You can send me stuff that doesn't quite fit, or I need for other stuff, or especially in the suffix case, you can send me pieces at the end that I can't actually write out to the cache, or you can send me more, and that's what you actually need this for. And then it's an optimization to go ahead and do stuff that is cacheable in there or not. You got to have that to handle these edge cases. Let's see. So I'm going to talk about this a little bit because this comes up for a subject that people are interested in. This is what I learned recently about cache. So you've got the open directory for tracking. You've got the info vector, which is a continuation of alternates. Everybody know what I mean by alternates? All right. So we have this in, we've got an alternate here, and a new cache receipt comes in, and it says, oh, I don't like this alternate. I'm going to go get one. So it has this update key, which points in here, so it's updating, and it has its own little local copy of the alternate that it updates. And so it's not actually going to write this to the real vector until this write completes. So until this write for this alternate completes, it's not actually in the real data. So what happens is if someone else comes in, with a new reader comes in, we actually make a copy of this over here and then go through the writers and copy the pieces over here. So this is what, when you do the alternate selection, it sees this synthetic vector over here of objects.
Maybe a couple words about alternates.
Okay. So you have a URL.
Alan? People might know them more as variants.
Variants? Okay. So it's the same object stored in various forms, like classic forms, gzip versus non-gzip, essentially by language. I know one group that did this based on resolution of the video. So you have the same video object, and the alternates are copies of it at different resolutions. You do this for images. Another technique for doing that. That's actually been discussed inside Yahoo about making more alternates and then saying all the resolutions are just different alternates back. Serve them faster.
Given your cache expertise, do you want to say a little bit about the trade-offs between storing different representations as alternates or different cache entries?
All right. I haven't thought about that a whole lot. So if you have different cache entries, then you have to have your user agent be aware and correct the construct URLs to get them. If you do it as variant, then it can be in a header, or you can have a plugin, which is what the people I was working with did, that knows the type of device you have and then selects the alternate for you when it ships the content back. So if you have it as a URL, it gives the user agent more control over what it's fetching. If you put it as alternate, it gives ATS, the origin side, more control over what content is being sent out. And alternates can also be more automatic, so if you, particularly like the gzip case, you don't have to worry about having different URLs for your gzip or non-gzip or setting those. You can tell ATS just to do that variant on its own and copy it out.
What about stuff like lifetime? The lifetime of the object in cache have different behavior, whether it's an alternate or whether it's a separate object?
Actually not. Each alternate stores all the headers, so that when you touch the alternate, it decides whether that alternate is there or not, and that's done independently for each alternate.
So there's two real issues here, right? One is the sort of slots for alternates is fixed size, meaning you set it up as part of the cache initialization.
Yes.
So default today is what, like 3, 5?
5.
Oh, the max is 5, the default is
No, the max is 1 on 5, isn't it?
no.
Really?
Yeah.
Are we positive?
Medium positive.
You mean the max number of alternates for one entry is max is 5?
I think so.
We set it up really high, like to like a dozen or something.
Default is 5, I think.
Default is 5.
Yeah.
Well, it's a compile switch, right? If you build a new.
No, it's a regular
No.
fixed setting.
Setting.
Let me double check that, but I thought.
Yeah, you're probably wrong, but you can go check it. The other thing that's scary is that finding these alternates, the linear search,
Yes.
which means if you were able to set it to 1,000, you could have to traverse 1,000 alternates to find the right one.
Yes. And what's really fun is that the alternate selection, especially use the plugin, is a synchronous callback. So it blocks the cache while you're doing the alternate selection.
I think in almost all cases, the way it's laid out today, you're better off doing what James did before, which is to basically put this logic into a way where you modify the cache key instead. You look at whatever headers you think are relevant to the variant of the alternates. You create a unique cache key for each one of those variants.
You can do that. It doesn't make much difference in terms of cache storage. The alternates will consume as many directory entries as the.
Except for those two downsides, which is fixed size and linear search. Because once you generate the cache key, it becomes 41 or 41.
Yeah.
But the purge behavior, I think, is probably better with.
The purge behavior is much better with alternates.
You have one key to purge,
Yes.
and you call the alternates. Whereas I think one of the problems we found with manipulating cache key is you can't reverse the process.
It's
You
impossible
can't
to purge.
find all the objects which were derived from this base cache URL.
Unless you have some other meta information outside of the cache itself.
To me, the kind of universally valuable thing about alternatives would be to have only ever use 2 of them really, and if the second alternative is used in something that's ultra low bandwidth, so you could flip your entire architecture to serve low bandwidth in dire situations. So if you're under attack or you have some sort of egress or failure, you could flip the cache to always use the low bandwidth alternative no matter what client asks for.
Yeah, well, that's what, as I said, the people I worked with did that. They had the considered alternates were slightly to optimize bandwidth consumption based on the client. But at that point, they had like 5. They used 5 alternates for different resolutions. But you simply do what you said. You simply say, right now, just serve low bandwidth thing to everybody.
So
There's
you could
also
do that with
working
cache
on
key
the-
also, I think.
By Google here, where they added a new RFC. I don't know if it went on RFC yet or not, but basically for client hints, right? Yeah. So the client can give hints on bandwidth capacity and size of the screen and all sorts of other information that then are supposed to be used as part of the variant.
The advantage of using the variant in that case over the cache key is that it seems very difficult to force a low bandwidth option in the cache key before you know if it even exists or not. Right?
Yeah, you can search the alternates in the alternate selection and fill in ones that aren't there. They actually do that as a background fetch operation.
And that's the way it works now too, right? Basically, it goes through the alternates, and it has this logic where it calculates a quality value of each work variant, and you have sort of a lower minimum value, right?
Yes.
As soon as something hits the minimum value, I think it picks that one, right?
No, I think if it doesn't hit, if none of them hit the minimum value, then it's a miss.
Yes, but if it finds one that reaches the criteria, does it pick that one? Or
I don't think
does
so.
it still go through all of them and pick the highest one?
I think it picks the highest one. I think it goes through all of them.
But regardless, you could do exactly what you said, right, where it might not be the perfect one for that particular client, but it's good enough.
Yeah.
And then you avoid going to orbit.
Remember that's the default stuff. There's a hook. There's a hook. If you want to take control and do it differently, then you can do that. So you could in fact implement the first match semantics if you like. That was important to you. All right. So what happens is we have an alternate, and the request comes in. We've gone out, as you saw in the picture, and we're requesting that. We're waiting for the headers back, and the second alternate selection comes in. And this is an issue that comes up a lot. I know Saveer's done huge amounts of work on dealing with this issue. Is you can wait for the header to come back. Say, well, I can't really do an alternate selection until those response headers come back, because I can't see what actually came back. I can't tell what resolution it was, or whether it was there or anything. So I should really wait. We also want to prevent the buildup of pending requests. So each time you say, well, even though there's another one pending, I want to do another origin, where do you stop if all these guys are requesting the same object? You can't know that until the headers come back. So you'd like to wait. However, there's a lot of situations where waiting for the headers is unacceptable. Right? You say, I simply don't want to wait that long. I don't want to delay surfacing. It's better even to get an error than to impose additional delay because these headers haven't come back quickly. Which is different than the stale where you validate issue. Now, this is one of the things that happens that we see in the current caches, because basically the cache object gets locked while these headers you're waiting for them to come back, which slows things up quite a bit. So this is what it looks like. The request comes in. There's no all. We say, okay, well, let's go off to the data center and get some stuff. And then before the headers come back here, the new alternate selection comes in. And we say, well, what can we do? We can't examine this one because the headers are incomplete. And so normally what you do is you wait till after response headers and then do your alternate select. But that's not in high performance video. I mean, yes, Saveer can talk a lot about this. You just can't do that. So one of the things I want to look at here in this regard is to set up two configuration items, wait time and the timeout action, to say, well, I'm willing to wait this long for the headers to show up. Right? Because that's really what you want to control. I'm going to say, I don't want to delay more than n milliseconds waiting for headers to show up. But then the question is, well, you wait and it times out and it doesn't work. What do you do? So we have to have a set of options here. One is to just say only return error code to the user agent. This is actually frequently preferred one because a lot of these user agents can deal with the failure and will do something recover-ish, retry or use old data. What we want to do is select from the existing alternates to say, well, I'll just pretend that other one doesn't exist and try to pick from what's actually already there, right? And give up the chance that what I'm looking for is the thing coming in. But then you still have to deal with the fail there. You can say, well, go to the origin anyway if I can't find what I want, or actually get the valid selection. Make any sense? So I want to try to set this up, but that seems like the reasonable approach. This should satisfy what people are going to want to do.
It has some similarity with what Sudhir has for the write lock fail.
Yes,
this is after that.
This would replace that.
Oh.
Again, to fix it correctly, you have to really muck about in the deep cache architecture. Right? This isn't doable without the other changes that I'm making. So, but once we've made those changes, this is not that hard to do, right? Because we've already put all this other effort in and changed the way the whole cache interaction structure works. We can do better on this.
So I'm wondering how this interacts with the fragmented approach with the POC.
Well, that's a fun question. So what you can do is you still have to, you have to fall back here where you say, well, I want to go for look at the selection, but it does not in fact have my, all the pieces that I need, not all cache. In that case, we consider it a cache miss. We say, no, we reject your selection because it's not what you need. You say you want this data and it's not actually there. So at that point, we have to consider it a miss, and then do the miss action, which would be either to go to the origin or go ahead and fail.
Yeah, I guess my confusion is we had this concurrent requests, multiple of them. Each of them finds the same gaps in your layout. How do you know? And each of them starts trying to fill those gaps. How do you prevent them from doing multiple times? Basically.
Oh, okay. That's actually all right. I'll address that in a moment. I'm gonna say that's a different question. This is talking about situations where we're waiting for. We have an outstanding credit. We're just waiting for the headers to come back.
Right.
So we can see whether that alternate is what we're looking for. So once the headers come back, then we have a different situation, which is where in your case. In that case, what happens is we actually, when we look and we say, here's the request with this, with these fragments, and here's the alternate with the data. And we look and see what's cached. We also look at what's being written. And so we say, if things are being written and the things you want aren't in cache but have already been requested, then we will wait for that data to show up.
But you know that they've already been requested?
Yes.
Based on the write log?
Based on the readers, we have a list of the.
Okay.
I knew this would come in handy. We have a list of the writers for the item here, so we can walk that and say, well, what does this request look like? Does that cover my cache? So we walk those, right? And that then ties back to this problem here, right? Because when this comes in, we say, oh, well, I walked the writer, I choose this writer here, and it's getting my data, right? But I know that you don't want to wait this long, right? In that case, we will do multiple requests out. And that's why that's important to be tunable, so you don't do that a lot. You can adjust how long you're willing to wait, trade off how long you're willing to wait for how many times you get the origin. But again, we stack it, we can have a list of writers, so the third one that comes in, if it comes in here, we'll see this one. And we'll go ahead and wait because that's close, right? It's the next thing that's coming in.
So it seems like you'd have to be really careful with how you set up behavior if the alternate that you were requesting is missing and you're doing byte range requests at the same time, so you don't switch alternates in the middle of a byte range request.
Yeah, well, what happens is once when you come in, before you do any operation here, all right. Before you do any operation, you have to commit to an alternate. So before we send a request out, before we update any of the data, you commit to a particular alternate, and then it can't be switched later.
If they are in the same session.
No. Well, a given transaction comes in, and before we do anything with it, it has to pick an alternate. I'm going to commit to this alternate, and that transaction has been locked.
Mm-hmm.
And you can't switch later, so we can do the things that we need based on the data for that alternate.
I guess I was just thinking, like, if you connect a second time, send a new byte range request for another chunk of the file, but that chunk is missing in the alternate that you got before, and then your fallback behavior is to use a different alternate. And the byte range request would become invalid, wouldn't it?
No, as soon as the byte range request, yeah, if you have to fall back, in that case, you still get this, yeah.
I guess you'd have to pick fail as the...
Yeah, you're still waiting. The whole thing is if you're waiting, you can't do your alternate. Oh, golly. There we go. Yeah, this case, you come in the second request here, what you're blocking out is alternate select because you don't have these headers. And so if you decide to go ahead, you just pretend this request doesn't exist. Because we don't even know where this is gonna, we don't even know what this is gonna get back. This could just fail, right? You just say, this is what I have, and if it's not there, you have to basically give up. You have to either serve what's in there or fail, or say, I'm just gonna go ahead and create a new request. We have to disable the cache for that request. So that request, if we do this fallback, disconnects from the cache, and none of that data gets cached. Because you don't know where it's going to go. So sometimes that's acceptable, sometimes that's not. That's why it has to be a configurable behavior. Not everyone wants to do that, or wait the same amount of time. How much time do I have? All right. I'm going to skip this because you guys don't care. It's It's just a fun little problem where, we have this alternate, you get the square alternate, so if you have a second one come in, it gets its own copy of the alternate, both of which go into the override slot. So I'm gonna have to change, this is what I'm working on currently, I'm gonna have to change it so we have, a stale vector and an update vector, and these guys can then share this piece of memory here, and so we only have one copy up when we go up here. And then we have some cleanup issues with that. So this is also how you can do stale where we validate, right? So the stale thing is still here. This is one of the reasons it's so much easier in the core. If you're outside the core, you can't see this thing because the alternate selection overrides it with this copying operation. But in the core, I can get to this and serve the stale content. So that's why that's a lot easier.
So one more question on generation of alternates. Does the origin have to follow the same rules for deciding which alternate to serve as the cache does then? So that
No.
How would you signal to the origin which alternate to?
All you can do is send a request. If there's alternate selection that's entirely based on the content of the request, then anyone can do it however they like, and there's nothing in the spec that says how you're supposed to do it. So our alternate mapping, our mapping to alternates is independent of what the origin does. It would be good if you consolidated those, but there's no requirement that you use those. So again, in the image case, right, the origin they were going to actually only serve one resolution, the highest resolution. They would then do their local transforms to stuff, their own alternates.
Oh, so alternates are being generated as cache.
They could be. That's one thing. Or they could be. We don't see. From the point of view of the HTTP protocol, there are really no alternates. You send a request and you get a response.
Right.
And that's it.
As being more familiar with the user agent side, I kind of always expect the URL to give me the same thing back.
Yeah, well, but if you say transfer encoding, if you set your transfer encoding, you can get different stuff back.
That's true.
Right? You get a gzip versus non-gzip, right?
A lot of times people do language header as well.
Mm-hmm. That's a good point.
Okay, so, all right, you guys don't care about this either. So I'm working on the cell where you validate. I need to deal with the fact that Open Directory isn't updated until it finishes. Cell object's still there, and you still will error. And that's it. Any other questions? That's really trailing off. So I am working on this. This is ongoing work. I'm hoping, every time I say I'm hoping to finish it this quarter, so I'll say it again, just because I would really, really like to get this done though. I think it's going to be a major improvement in how EPS works. With video coming up, we have to get this feature in, so we can do better video serving.
So Alan, on the question of compatibility again, I know you said you can't go back, but even to go forward, do you need to dump your cache or?
No.
Okay.
No.
When you say you can't go back, what you mean is objects that are written on new version of ATS can't be read by the old.
Not currently, no. Actually,
But it doesn't dump the whole cache.
No, it doesn't dump the cache.
Downgraded without ever serving.
No, yeah, so because it can read the old ones, it doesn't change anything in the cache, it just writes new objects in the new format. And eventually, because it's a circular buffer, eventually you'll update everything to the new cache. So slightly slower, not a lot slower, pretty trivially, to read the old objects, that's to do a format conversion. But eventually your cache gets naturally upgraded to the new version.
Yeah,
But that's different than the old one, because it used to be as soon as you upgrade it, start it like you can.
Yeah. That's not even true.
No, but by not going back, that's what I mean, right? You won't be able to use the cache anyway. Let's say you've turned on this and you see some problems and you want to turn it off. Basically, as if you're starting with zero cache, right?
Yes.
That's
how long
what
it's been running.
What?
No, it's really not going
Because
to.
if you turn, let's say, like I already have like, my cache entirely full, I turn it on, I put it in rotation for like 3 seconds, I take it back out and go back.
I would have to consider that risky. Because if the new one hits one of those new objects, it's going to try to read that in and just get confused. But I could put some protection in there.
The old one shouldn't be able to just ignore it, right? If I roll back, it should just be like, I don't know what this version is.
There's no code in there to do that. I could do that, though.
Oh.
All right. Again, that's not very hard because it's per object. So we can say, okay, that object is a future version. I'll just pretend it's not. So, yes, that could be done. For you, Thomas.
Thank you.
And I think some other protection things that might be worth are if you know that a particular origin doesn't support byte ranges, I don't know, based on one response or based on some setting, you don't do these fragmented up, or you somehow don't trigger these gap filling requests to them. Because it's costly, I can see that it's costly to figure out these gaps, figure out the coalesce them and stuff, and then make sure that you're not repeating things and stuff. So you could avoid all this if you know that the origin doesn't support this.
Yeah, I'm not sure that you're devastating there, because if the origin doesn't support it, the first time you hit it, it's going to give you the whole object back.
Yeah.
And after that, the whole object is there, so.
But I'm thinking of the case where it's a concurrent request. Let's say you had a request
No,
for
it's
0 to
supposed to be
1
that.
and 1 to 100, and let's say you issue 2 requests for these 2 distinct requests and ranges, and you got 2 full objects back. You could DDoS that with 2 distinct ranges in one shot.
Yeah, I guess I can look at that. I'm not sure that there's a lot of served origins. Are there origins out there that don't have no range requests?
A lot of origins don't support ranges.
Really?
I think so.
I mean, actually,
All right, just sorry. Okay. Put in. More future objects. Yeah, I'm not sure what you can do if you get a bunch of I guess if you mark it for origin. So the first request to that origin, there's nothing you can do, right? Because you don't know. But I guess you could look and say, okay, well the last time I talked to this origin, I asked for a range and they gave me the whole thing. You have to look at it. That's a little tricky because some origins will say, well, if you requested more than half of it, it's quite reasonable to say, well, let's just give them the whole thing.
Exactly.
In which case you're getting a false positive there.
We could at least have a static configuration for origin. I don't know how practical it is, but just as a defense.
Yeah, I mean, I'd probably look at transaction config override. So your plugin could say, yeah, mark this as not acceptable.
You have to rewrite and remove the range request, the range header.
That rewrites the solution.
Oh.
There you go.
Just make a new one.
Some origins blow up when they get a request.
There we go.
No, but there are definitely origins.
Really? What are they running on? Apache.
But that's totally not allowed, though. You can totally do the.
Oh, yeah, they're completely allowed. Really, honestly, I read the spec very, very carefully about this, and frankly, the origin just do whatever it wants, regardless of what the range looks like. It is just that lots of should, but no must.
You can't give wrong information. You can't say that the range is one size and send something else.
Yeah, but it's
Yes,
basically.
it can. If you ask for a range X,
Yeah, but if the response says this is byte 0 to 99, and
it has to be byte 0 to
it
99.
has to be 100 bytes in that range.
Yes, and they have to be the actual those bytes, right? But it can just pretend you asked for something completely different,
Yes.
respond to whatever was in its little head. If it wants
It has to
to.
be correct.
Yes, the data has to be correct, but.
So
Yeah.
and also a lot of times, even though the real origins may support range requests, sometimes use these proxies in front of them which
Yeah, I
don't,
suppose there's that, yeah.
which don't support. So we actually had that Yahoo recently. S3 origin supports range requests, but there was a proxy that they were trying to support,
alright,
which doesn't support it, so it would basically drop range and send the full request to origin, and you get these full objects back.
Like ATS does.
Yeah.
All right.
What's your test coverage look like?
You're just mean. Very bad. It's one of the things I've been pushing Jason really hard to get the test framework up, is because I want to use this test framework to do this. I'm making him. So remember we talked yesterday about doing the function checking of the data that comes back, where you can run a function to the goal test. I wanted to do that precisely so that I can get better coverage here.
This also seems like the kind of thing that's extremely difficult to get good coverage of if you only have.
And I'm not sure, yeah, I'm not sure how you do unit tests, that would be even harder.
Well,
I think a
there's,
lot of the stuff, the actual range request, that sounds perfect for, send weird range requests, have origin that ignore it. Weird range requests, origin ignore it.
right, but you have these complex internal data structures and multiple layers of stuff. I think we should think about having different kinds of tests at different
Yeah, I do
layers.
have-
Like, I mean, you have this whole, in the code, you have this whole new abstraction about ranges. The unit tests for that?
No, not for that, I did end up writing some unit tests for the site content buffers, because I had some bugs in that.
Yeah.
So I've been, that's actually something I'm working on, is unit tests to get the site content buffers to verify that they in fact, because you have to do this unification, because the origin can send back whatever, and you can end up with cases where you have a thing in the site content buffer, and the thing that's coming in overlaps them in odd skewed ways. So I do have a building unit test for that. So I am building unit tests where I can, but a lot of this, like fixing the alternate collection, for instance, it's really hard to do that without a full-up integration test. So yes, that's a concern, and hoping that the unit test and Jason's friends will let me do a lot more testing.
So I guess also like integrating this thing, integrating it as one giant chunk is
Scary?
kind of terrifying.
Yes. Unfortunately, I really don't see how pieces can be broken out. They're all so tightly integrated together. I guess we could try doing the internals with the ranges without actually processing range requests. So,
I mean,
but it's so useless. I'm not sure.
I think that you have to find a way to break parts of it, otherwise.
All right, we'll have to take that offline because I need other people's time now. So, yeah, so I'll be around. So if you want to bug me about that, if you're not changed.